Hello everyone, welcome back to our channel. Today I'm excited to show you a powerful tool that simplifies SLAM-seq analysis dramatically. With just one line of code, you can run most of the SLAM-seq analysis. So SLAM-seq is used to calculate the half-life of mRNA, but to get this is crucial first to calculate the conversion rate of the transcript, and this is what our line of code will provide us. So first let's refresh what the conversion rates are, just to understand what we're doing. Each gene can produce a transcript, or actually a series of transcripts, and typically you have the T's, and in most of the cases there's no mutations, but in certain instances we will have mutations, especially when we add our mutagenic agents. So once in a while a T will be converted into a C. So now the conversion rate will be equal to the number of C's that we have in the T positions divided the number of C's plus the number of T's. So in this case we have a mutation rate of 1 in 4. Okay, let's get everything set up on our computer to run the first analysis. What we need to do first is to download the code from the Slamdunk GitHub repository. The code itself calls the Docker image with all the software we need pre-configured for our convenience. So here we go to the T Newman Slamdunk repository, we go to code and we download the file, and that will contain all the code that we need. So in this case I created this folder. We have here the code we just downloaded from GitHub, and here we have the data. We had FASTQ compressed files and this sample info. This file links each FASTQ file name with its respective condition and time point. So this is how the sample info file looks like. We have the different conditions, the name of the sample. Now before we launch our pipeline, there is one more step, ensuring Nextflow and Docker are installed in your system. Alright, now that we have everything set up, let's dive into the course of today's tutorial, the single line of code that lets us run most of the SLAM-seq analysis using Nextflow. So this is the line that we are going to use. In this command, the ns SLAM-seq is the directory containing our GitHub repository code. The simple info tsv is our metadata file that organizes all of our data, and the hg19 is the genome assembly we are using for this analysis. However, if you try to run this line of code right now, it will likely break due to several reasons. First, you might need to specify the version of Nextflow we are using, especially since the pipeline requires an older version of Nextflow. So here's where we specify the version that we want to use. So by setting the nxf version variable, we inform the system which version of Nextflow to use. Moving forward, let's discuss optimizing our pipeline to fit the resources available on our system. One of the parameters I found necessary to adjust was the maximum number of CPUs allowed. For our setup, we are using the max CPUs 8 flag. So to launch the pipeline, first we need to go to the directory where we have the scripts. So once we are there, we can launch our pipeline. So that's the pipeline working. And you can see here different steps and the progress. So it started with this step here, but then needs to do the mapping, the detection of the SNPs, the count, and the reporting. So you see that here it makes progress in different steps. And this is all done automatically. There is no need for us to intervene in anything. Everything, the order is taken care, and so it's very hands-off. To address a failing process, you'll typically go to the main NF file within the pipeline's repository. In our case, since the TC per read position step isn't essential, we can use the error strategy ignore flag to proceed without this. So if we go to the main NF and we look for this TC per reads post process, we can add this error strategy flag ignore. So this will be ignoring the process and moving on. If your pipeline does encounter an error and stop, you don't have to start everything from scratch. You can use the resume flag. Here's how you integrate that into your command. So here we artificially interrupted the pipeline, so it says this job failed. We don't really need to fix much here, but we want to say that to the pipeline to continue from that step. So we just add that flag resume at the end. Before that, we'll need to remove from this folder pipelines this trace execution file. We'll remove that, trash, and we run that again. And you will see that the pipeline is running, and you see that already made this step and set cached, that is the files that were already run. So this is not being run. And there it goes, it continues running from where it left. Okay, once the pipeline has successfully completed, you'll find all the results waiting for you. So let's look at this example that already completed. If we go to results, Slamdunk, count, and UTRs, here the TSV files. I also have this Excel file that is a conversion of one of these TSV files. And you can see here that you have the name of each transcript, and then you have here in column G the conversion rates. And that's it for today's tutorial on setting up and running the big or important part of the SLAM-seq analysis pipeline. If you are interested in learning how to take these conversion rates and estimate the half-life values of transcript, make sure to check out my next video where we'll dive into that process. If you found this video useful, please give a thumbs up. It helps make this content more accessible to others that might find it beneficial, including yourself in the future. So I'll see you in the next video, and until then, happy analyzing.